welcome to today's video. This is going to be over how to solve for acceleration. So first we'll look at the front of the worksheet that you got in class, where it talks about the differences between speed and velocity. Speed is just distance divided by time, but velocity is speed with the direction. Okay, so put a big star by this statement right here. Velocity changes when direction changes. So if it includes a direction, 20 meters per second north is different than 20 meters per second west, which means that if someone is moving and they make a turn, that is acceleration. Okay, so speed is scalar, velocity is vector, acceleration is a vector. Vectors just mean they include the number, the unit, and the direction. All right, acceleration is how fast you change velocity or how much the velocity changed in a certain amount of time. An object accelerates when it changes speed or changes direction. This will be one of the big things we ask questions on the test, and we have to make sure you understand it. All right, so the change in velocity, so you take your final minus your initial, and you divide it by your change in time. So when you find your change, it's always the final. The second event minus the first event is how you always find changes. It's kind of like when we find slope, it's y2 minus y1 over x2 minus x1. So it's the second event. It's how much it changes. It's the second event. If the second event is larger, then you'll have a positive. If the second event is smaller, you'll have a negative. All right, so a plane starts at rest. How fast are you going at rest? Okay, if you start, that's your initial speed, VI. Ends up going 200 meters per second, so that's his VF, final speed. 10 seconds is time. So you can underline and label, or you can write them over here like this, either one you want to do. Formula is A equals delta V over T, or you can write it as VF minus VI over T. So the second is 200. Minus 0. Make sure you put those in parentheses in your calculator. If not, you'll get 200 minus 0 and get 200. So we'll work on that in class to show you what I mean. All right, so 200 divided by 10 is 20. The units are meters per second squared because it's meters per second divided by seconds. All right, a race car starts at 40 meters per second, so that's his VI, initial speed. He slows to 10 meters per second, so that's his final speed, and it takes 5 seconds. So this time we have a smaller final speed. So when you see the numbers down here, it's 10 minus 40 to give you 30, actually negative 30. So negative 30 divided by 5 gives you negative 6 meters per second squared, and as they say here, that means you're slowing down. It's also called deceleration. All right, using our dots on the grid here, if the dots are evenly spaced, then it's a constant speed. If the distances are getting bigger between the two, that means you're accelerating, getting faster and faster. If you read it left to right, you'd be going, okay, if he goes this way, then he's getting slower. The idea of getting slower would be dots that are further apart that start getting closer together. That would be slowing down. All right, and measuring acceleration, they might tell you how far you went at the very beginning. We're going to do this with our lab activity tomorrow. And then you figure out your speed at the end, and you take the time in between the two. So over here on the right-hand side, our second speed was 8 meters in 1 second, so that gives us an 8. Our first speed was 4 meters in 1 second, and that gives us a 4. So 8 minus 4 gives us 4. 4 over 2 is 2 meters per second squared. This is what we're going to do in the activity. You're going to solve for the beginning speed, you're going to solve for the initial speed, and we're going to give you the time in between, and you'll solve for your acceleration. All right, so go through here and look through the dot program and figure out which ones of these you can call constant speed, positive acceleration, constant velocity, accelerating, decelerating, blah, 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 blah. And I'm going to pause the video while you work. And you should pause it also, and then when you come back, the answers will appear. All right, so here are your answers. The one that kind of depends on how you look at the questions is distance increases over here. The distance between the dots increasing would only be object B. But in all of these, since they're moving, the distance will continue to increase. You'll build up, build up, build up distance because all of them are moving. The other one is over here on accelerating. We're going to call acceleration both positive and negative acceleration. So A is decelerating, so it's the answer for decelerating and the answer for negative acceleration. And B is positively acceleration. Object D has a constant speed, as we see here for the very first answer. C and D have constant speeds because the dots are evenly spaced. But because it's changing direction, it is accelerating. So the speed remains constant, but the changing direction means that we are accelerating. When we talk about Newton's laws, we'll talk about the idea that it takes a force to cause something to change direction, and a force will always cause acceleration. All right, so math problems. So what I want you to do is underline what they give you. Meters per second is always a velocity. So what you have to decide is which one is the initial one or the first one, and which one is the final or the second one. Okay, so initial velocity is 2, final is 6, time is 2. That way you don't have to write over here. Formula is A equals, I'd like you to write it as VF minus VI in parentheses over T. Solve it means you have to plug your numbers in. 6, remember it's the second one first. 6 minus 2 over 2. That gives us 4 over 2. And the answer is 2 meters per second squared. All right. A dragster's top acceleration is 60 meters per second squared. If it starts from rest, if you start at rest, starting means that's your initial. At rest means your VI equals 0. So that means your VF is 60. And how fast will it be going after 3 seconds? Oops, this is your acceleration. My bad. All right. So how fast means you're looking for VF. All right, so this one's a little bit harder for what we're going to be doing. So A equals VF minus VI over 3. All right, what makes this a little bit easier is the fact that our VI is 0. So when you plug it in, it's 60 equals VF minus 0 over 3, which means we have 60 equals VF over 3. Multiply both sides by 3, and you get VF equals 180 meters per second. Paying attention to your units, the idea that velocity is meters per second. A plane stops from 250 miles an hour in 25 seconds. 25 seconds is time. Miles per hour is speed. Stops, okay, so now we got, stops means you're going to be 0, okay? So what we have to figure out is stopping our final or our initial. Stopping is your final, from 250 is your initial. So formula A equals VF minus VI over T. A equals 0 minus 250. Notice how we label them. VI goes second. If we're stopping, shouldn't we be slowing down or decelerating? Okay, so what we have is negative 250 over 25, and that's going to be negative 10 meters per second squared. Notice that the 2 goes right next to the S. It doesn't go out here on top or anything like that. It goes next to the S. It's the seconds that are squared, not the whole thing. Another way to write it is you could actually do it as meters per second per second. You'll see that every once in a while. All right, a car travels 30 meters in 5 seconds. All right, so on this one, we're going to have to find our velocity because this is time and this is distance. After accelerating for 3 seconds, that's time. It travels 20 meters in 2 seconds, so that's a distance and that's a time. Okay, so this is our first, this is our second. So VI is V equals D over T. So 30 over 5 equals 6 meters per second. The second one is you travel 20 meters in 2 seconds. So V equals D over T equals 20 over 2 equals 10 meters per second. And then A is VF minus VI over T. So 10 minus 6 over the time of 3 seconds, because that's the time between each event. So that's 4 over 3, and that's 1.33 meters per second squared. All right, last one. See if you can do this one. Should be pretty simple. I'll pause the video and then I'll show you the final answer. Okay, you should have been able to label that the taxi started from rest, or the jet started from rest, which is 0, so VI equals 0. So that's right, equals 0 up here. And then the final speed is 75. That's when the plane would take off. It took about 6.5 seconds. So 75 minus 0 over 6.5, 11.54 meters per second squared is your acceleration. So this is what a jet has to accelerate. This is a small jet, not a, like I said, called a jumbo. Got this information from somewhere. I don't remember where it was though. All right, well, good luck with acceleration. It's pretty simple. You just have to do everything straightforward. Good luck, guys.